Hey guys, it's me with the tie, and today I'm going to be talking to you about how to build your own CLI agent. So you might have missed my video where I was chatting about like what are the differences between a lot of these CLI agents. There isn't much difference at this point in time. It's mainly just in the way that things are displayed. And I think the reason there isn't much difference is because the whole concept is very, very simple. And we're going to discuss it today. If you have had any questions around how to build AI agents or what even is an AI agent, hopefully you're going to get those answered today. Essentially, an AI agent is a LLM feedback loop where the LLM is asked to perform a task and it will continue prompting itself and performing said task until it is complete. The diagram here explains it, talking about starting the chat session, getting the input, empty input, adding to the conversation, running inference, and then executing tools. Now, most AI agents operate using this execute tools feedback loop, or the execution loop as they've called it here, where they go get that tool, execute the tool, capture the results, and then they add those to the LLM, and then the LLM responds based on what it's picked up in those tools. So hopefully that explains it a little bit. If it's not clear, we're going to make it clear because we're going to be building an LLM tool in Node. Now, the author of this particular article inspired me by saying, let's build an AI agent. He built it in Go. I am going to build it in Node. So let's go to the codes. So just before we open up our editor and start playing around, the important thing to note is that our architecture, which we're going to be building, is going to be based around the CLI entry point, which we're spinning up with Command.js. We're also using Readline interface in order to create our CLI tools. These are both very simple frameworks for building CLI tools in Node. We're going to demonstrate a basic system loop using read filing and file explorers. I challenge you guys to go through and actually build up this architecture for yourself and then extend it using edit. You can probably use node edit in order to make it function. For now, let's clear out everything that we've got here, and we're also going to clear out everything. Actually, we may as well just go through and delete all of these files just so that we can start fresh. Cool. And the first thing that we're going to want to do is to bring up a terminal. And I'm also going to zoom in a little so that we don't have PNPM installed. I recommend that you install that. So I'll run that. Okay. Now that that's done, we want to install a few packages. So we're on pnpm-i. We want to install Readline, Commander, and we also want to install at Google, I think it's Gen8, just double check that. Yep, then we'll install that. And those are the three packages that we're going to need in order to actually start executing on these things. Finally, in order to get our CLI tool running, we need to navigate to our package.json, just move out of the way, and we're wanting to add in a few lines. We want to add in this bin line, and this bin is going to actually create an executable binary that we can use. We need to make sure that we have that comma up here, and this is where we're going to name the name of our AI agent. I'm going to call this one best, and I'm going to put in here the entry point is going to be Index.js, because that's what our index is going to be. Then we want to make sure that we set the module to be, we want to set type for this package to be module. And that's just going to mean that we use an import syntax, kind of a big explanation of what this is used for, but it basically enables us to use import syntax inside our file. And then the next thing we're going to do is we're going to create our index file here, index.js, and we can start actually building the program. Now, one thing to note is because we're using this program, we need to add in this up at the top here. This is going to enable us to actually execute this as a script or as a command line tool using Node. So we'll add that up there for execution purposes. Then we're going to import program from Commander, and program, we're going to give it a nice description. In this case, we're going to call best AI CLI tool. We're going to give it an option. This one we're going to call -v -verbose. We're going to say set to verbose mode. We're going to add in a default of false. And this is going to be what we're going to use for troubleshooting. Oftentimes CLI tools have a verbose mode in order to make them actually behave. And we're going to also want to set in a API key with a type here, which will allow us to Gemini API key, and we'll just leave that as is for now. Now we want to make action, and then we want it to have its output be process v, which allows it to process any arguments that are asynchronous within this loop here and then output them. So for starters, we're just going to run log, and then we're going to log the input as received input, I think, receive, and we'll see if this one goes through and fires. First thing we've got to do as well here is just run npm link, and that's just going to link up our package. So what your tool is going to be called is going to be best AI, because that's what we've put in the bin here, and it's going to use this Index.js to build. So we'll run it by going best AI, runs through and actually just outputs that straight away, which is really good. It says that the verbose is false. If we put in -v, it will say verbose is true, which is great. So with that being said, now it's time to get into the fun stuff where we actually set up our execution loop. And to start with, we're going to want to first scaffold our AI. I'm just going to copy paste in the command to do that, which is going to be our Google Gen AI. And we want this one up here as well, where we go import Google Gen AI. And then we'll also showcase verbose command looks. So if input verbose, then we'll just log here Gemini initialize. We'll run our AI again. It's decided to complain about something or other. API key is not defined. What have we done here? Set our API key. All right. So I've pre-prepped an API key from earlier, so I will make sure that we put that in, dash, which is the key that we've defined here. Chuck that in, and then let's see, options is not defined. That's because we've got this up here, input. Let's just add in that input and run that again. Yeah, we've got our API key. Great. So now that we've got that in there, we can start querying the AI itself. And I think a good way of doing that would be to see if we can go, and then we can have a message in here, which can just be role user. Then I think it's text, hello. And then we can put in res.text, which will hopefully output a nice response. We received undefined, which is not what we want. So let's just log our res here. I think we need to wait. There we go. And we get that back. So let's log our res now with the text. Great. So we've already got a chat interface coming through with all the fruit, which is what we want. Probably get rid of this received here. What we've just created here is what I would like to call a workflow, which is where we use a program in order to make a query to AI, and then that query just returns. There's no agent involved here. And also, this isn't just my definition. This is something that Anthropic says. There's two sorts of ways that we see AI being used for developers. We have AI workflows and AI agents. So this is a great example of a workflow where we run a command. In this case, best AI is run with an API key, and then it returns a response to the question that we ask here. Now we're going to get into the part of actually creating the loop, which is the important part of a agent, because we create an event loop which allows us to loop through the responses of the LLM. So we'll go async function here, and we're going to call this start interactive mode, and we'll give it some parameters. We'll give it AI and verbose here, and we'll expand this out. So we're going to reuse this function, obviously, in order to create our interface, but we're going to go. So the first thing that we want to do is create our interface for our read line. So we're going to do that by going rm, and then we're going to import from here Readline from Readline, and we're going to create this Readline, create interface. We're wanting to add in our input, and we want the input to be std in. It's going to be the input. Just want to make sure that's the right one. Yep. We want the output to be std out. Standard in and standard out, both input and output parameters for the console. I believe that under the hood, this probably uses C or some other language in order to interact with terminals in general. So it's probably going to be the case here. The next thing that we want to input is the prompt, which is going to be anything. But in our case, we're just going to leave it as that. Actually, maybe we'll call it best AI here. And then we also need to make sure that this actually gets prompted. So we'll add in rl.prompt in order to basically make this interface come to the top. We'll just comment out this generate content here, because I don't think that it's going to be very useful for the meantime. And we'll also comment out that, and we'll add in our start interactive mode here with the AI the verbose settings, which should just be input verbose. And then we can start this up. Gemini initialize, and we got this best AI where we can type in lots of stuff and it does all of that goodness. Great. So now that we've got that interface in place, the next thing that we need to do is we need to add in an exit command, which is going to allow us to actually exit the program. And the way that we do that is we do rl.on, and then we run this command here, which will basically say that, oh, when we see this being said, like exit, we will actually go through and exit. So when this happens, we'll go process on, and then process.on, we'll go process.exit, and then 0. And we'll also make sure that we write log goodbye. Now let's run that, and then we'll type exit. Why doesn't it work? Because I haven't added. So the way that this works is it's got different. So we just want to make sure that as it adds in online, we make sure we firstly collect the input. So we'll add in this input here, make this async because we're going to be running some async commands in here. And this just will get run every time that a line's typed. We want to first trim the input. So if we go font trimmed equals input trim, this is just to get rid of any white spaces at the end. We want to return out of this, and we want to also close the RL. So let's just go close. Then we can just test this in here. We'll just clear out that. Then we run our exit command. We've got an assignment here. So let's just make that exit, and then it exits. So we can probably add in this goodbye here in order to make it do its stuff. Get rid of this probably. Now let's see. Yeah, so it just finishes once we run that, so we don't even need that last line. So with that in place, we've got a way of actually exiting out. Now we need to process this trimmed input. So we'll run if trimmed, and then now the first thing that we're going to want to do is to make sure that we set up our AI agent inside here with some history. And to do that, we can start by creating a history. Firstly, I think we can probably do it actually outside of the LLM in general, but maybe we might want to, yeah, let's just do it inside this function here. So the first thing that we'll do is put it up here. We'll go let history equals, and then we're going to want to run this particular command here, which I'm just going to copy paste the code that I wrote earlier. And this will go through and trim up our conversation and make sure that it's pushed to the LLM as the user role. And then we can take our code that we wrote here and probably repurpose it. If we go, just bring that back, we can make sure that we add and push our history directly to the LLM. And this can be just left as history now. And we can probably just run every time that we run this, we want to push the history probably to the model. So whatever the response is, we want that to come through. So if we just add in these two lines here, we change this to response rather than read. This is going to log our response and then push that response. So we can just test that our history is running by just running this. Go, what is 5 plus 5? And then it goes through and responds with that. And we can say, what is 10 plus 10? What is the sum of all these numbers? And it remembers it. So we've added a memory into it. Now, something to note in this is we're still not at the point where we're running an agent. This is just a workflow, an LLM workflow, where we're querying the LLM. We're giving it all of the history, but at the end of the day, it's still a function call. And another thing to note is that we also want to make sure that we're, I suppose, logging the size of the history as we go so that we know what's actually being pushed through. So if you're building one of these yourself, you probably want to be making sure that your history is being tracked as you go. So just add in a console.log to just say exactly what it's doing. I mean, we might just do that now and just make sure that after each response, we just go console.log. We can add in our if console.log history, just add in this info tag here, history, and then history.lengths go out of here. And you'll see that it adds 2 items to our array with this push, which is because that there's the response from the model, which is being pushed, as well as the original question from the user. So now that we've got that there, I think that we can look at perhaps creating the actual while loop, which is going to be used for our actual agent to do its stuff. Now, before we do anything, I would like to configure our tooling to begin with, and we can do that through this command here or through this constant here. The reason that I'm not showing you exactly how to type all of this out is because all of this is in the docs, and I just think it's going to be easier just to explain it. So the AI here, which we're using this library in order to call, beneath the hood, it's just REST call to Google's LLM, but we're going to put in this config here, and we're going to utilize these tools config. And here are the tweaks that Gemini requires. So what we want the agent's role to be, having it set to this particular command here means that it will perform as if it's a coding agent and will lend itself a lot more to getting the right responses out of it. The way that the LLM responds when we add this configuration in is that when we set tools for the LLM, it will recognize that locally there's some functions that it can run, which we've declared here along with their interfaces. When we set this tool config mode to auto, it recognizes that it should run these functions locally and not in some cloud environment. Like you would have heard of serverless where you can run functions in the cloud. These LLMs also have the ability to do that. So I just sort of noticed that that was there. I got rid of it. So what we're saying by setting to auto is that we only want these tools and these particular functions to be run locally. We have a name for the function, a description for each of the function, and then parameters. And these parameters and these types are assigned directly from Google Gen AI up here. So you want to import type so that it knows exactly what it's supposed to be looking for when it's going through and reading things. Now we create the actual loop inside of trimmed, and all is agents are just a while loop. So now that we've got our initial part here, which we're going to want to keep, we're going to add init to the agent feedback loop. So we're going to call this let iterations equal 0. And we're setting this agent feedback loop here to intentionally only have a few iterations because we don't want it to just run continuously. And we're going to want to run this while loop here, while call response function. And this is going to change the response, obviously, because we've got our tooling here. Response.function calls, because Google's going to want to call some functions locally on our machine, and iterations is less than 10. And now we're going to set up our tool call response function calls 0. And then we'll go verbose because we want to actually know what tool it's trying to call. And then we'll say tool iterations +1. Then we'll go tool call name, which is going to be defined up here in our structure here, where it says this is the tool that we're calling, and then any args that are included, tool called, or just an object, so that we get our args come through here. And now we can exit out of this, and I think this already should, actually if we exit out of this, I think it's going to cause some issues. We want to make sure that we add in this iterations into the mix so that it only runs a certain amount of times. We're also going to want to actually introduce the execution of these tools directly into our loop. And to do that, we're going to create an execute tool stack up here, which will be our function for actually going through and calling the tools one by one. So just copy pasted these up here. You'll notice that it's using import fs from fs, and this is just the node file system. So it goes through and will list the files directly from the node file system. It can probably be a little bit smarter in the way that we do that, but this is where you can set your local functions up. So if you wanted to extend with another call name to edit, maybe like if you wanted to use, I don't know, an edit file tool, you can do that. So, but let's chuck in our execute tool in here, and we can make sure that when we run this execute tool, and we'll just call const result. Once we call this execute tool, it will run our tool call, and that will execute our tool and get our result. And we can push to history that result. So we'll go to history.push, and we want to add in the following calls. Actually, I can't be bothered typing all this out. I'm just going to add it in and then explain it. We've got this new role here called function, which is actually going to be the response from a function call. And it's going to, because we're changing the output of what is going to be produced by these function declarations to the LLM on its side of things is calling, and it's got some special source which makes function calling possible, and include that in what we add to our LLM history. And then finally, we can add in the next AI response, which we can do. Oh, I've added these in the wrong place. Let's get rid of all of this and then go up to here, not to our tool execute, but expand out this. Just under here is where these things need to be. And then we can also grab this one, and this is how we're going to get our next response. And then finally, what we want to do is we want to display whatever the latest response is from our LLM. I think we want to make this response up here a let, because we're going to actually override that response as we go through. And then we can add these final responses in at the bottom of it here and tab it out. And this should go through and actually run as we would expect, with one caveat, because we've done all this, but we haven't done a try catch statement where we pull all of this stuff up. And then finally, once all of that magic has finally stopped, we can run a prompt again here. And I actually think that this try has got to be inside of this to begin with, and same with this catch, and then we can just format that. Yeah. Okay, and now if we run our best AI, we can say, what is the name of the CLI we have created? I do not have access to read this, so we can see that it's gone through and it's actually used the tool already. There is a read package.json, and then it can see that it's gone through and actually picked it out. So now what we can do is we can start playing with it. So let's create a little riddle for it to solve. And of course, I'm going to not make it hard for myself and come up with a riddle. I'm going to get ChatGPT to come up with a riddle. Give me a riddle and the answer. Okay, so ChatGPT says the answer to this one is an echo. It says, I speak without a mouth, hear without ears, I have no body, but come alive with a ring. What am I? So what we're going to do is we're going to exit out of our best AI, reopen best AI again, which I think I just want to exit. I want to clear this and then reopen best AI. Gemini initialize. So there is a rid located in this please use your tools to solve it. And it should go through, list the files, read the files, and then answer correctly. Now we can see that it's actually repeating the output a couple of times. That's probably because I've like logged it a few times. If we go in, I think that the issue is that we can probably remove that, and it's gone through and done that. Let's see if it does it again. Is a riddle located in this, please find and solve. There you go. Now it's fixed up the text. So what is different about this is that it is going through and actually looping. It takes the first result of the function call, goes and executes it, and it will iterate after it's gotten a response. Then it will call itself again and continue iterating. This is all an agent is, guys. It seems way more harder than it actually is, but at its crux, an agent is just a continual loop where we're asking the LLM questions over and over again. I hope this clears up things, and I hope you guys see the magic like I see. This is a game changer for me, because I thought that there was more to it. I don't know if you guys feel that way as well, but you guys can go now run and build your own agents, and this is alarmingly small for, you know, what it is. Like, most of this is just because of the formatting. So if you guys are interested in building more agents, if you're interested in technologies like Pocketbase, which I love, then check out my offerings there. I've got a newsletter where I talk a lot about AI, security, those sorts of things. If you subscribe to that, you can get information every week about cool stuff that's happening in the tech space, as well as tools and tips for making you a better developer. If you want to make apps very quickly and you need a good template in order to do that, recommend you check out FastPocket. FastPocket's the premier way of building with Pocketbase. It allows you to build with React, or it allows you, I think it's the best way of building a Pocketbase app. You get a front end out of the box, and it's very easy to get set up with Stripe and Bootstrap, Lemon Squeezy even. Very simple. So yeah, check that out. Just updated the docs, just updated to Astro, and updated also to Tailwind 4. So got a lot of premium stuff there. Thanks for listening, guys, and I'll see you in the next one.